A fuel cell is a device that generates electrical power through a chemical reaction by converting a fuel, in this case hydrogen, into electricity. Although hydrogen is in its infancy as a fuel source, its future is incredibly bright. The technology behind hydrogen fuel cells is improving daily, and its viability as a replacement to the internal combustion engine seems likely. A fuel cell needs three main components to create a chemical reaction: an anode, a cathode, and an electrolyte. First, a hydrogen fuel is channeled to the anode via field flows. Hydrogen atoms become ionized or stripped of electrons and now carry only a positive charge. Then oxygen enters the fuel cell at the cathode, where it combines with the electrons returning from the electrical circuit and the ionized hydrogen atoms. Next, after the oxygen atom picks up the electrons, it then travels through the electrolyte to combine with the hydrogen ion. The combination of oxygen and ionized hydrogen serve as the basis for the chemical reaction. A polymer electrolyte membrane permits the appropriate ions to pass between the anode and the cathode. If the electrolyte gave free control for all electrons or ions to pass freely, it would disrupt the chemical reaction. At the end of the process, the positively charged hydrogen atoms react with the oxygen to form both water and heat, while creating an electrical charge. Within the fuel market, there are many different applications with different power requirements. In order to provide adequate power, individual fuel cells can be assembled together forming a stack. A fuel cell stack can be sized for just the right amount of energy for the application.